He is the solution architect in the high-performance data division at Intel, and his role, Gabriel provides technical consultations to partners, customers. He evangelizes the Lustre technology worldwide. He's standing on my left. He's architected a number of high-performance computing storage solutions based on Lustre on a variety of hardware platforms since 2006. He's involved in several open-source projects and has promoted the adoption of open-source software and Linux in the enterprise since 2000 when he worked as a software engineer at Red Hat. Is that fast enough?
Yeah.
I don't want to butcher your last name.
Paciucci. Buongiorno. Buongiorno a tutti.
Well, you know, I mean.
Okay, here we go. Ooh. So, let's go to this topic. We saw today many interest in using ZFS as backend file system for Lustre. Through this presentation, I would like to summarize many of the POC that we follow in last year on this topic, and also understand which is the activity that we are currently doing in order to improve this backend file system for Lustre. So, ZFS is a very attractive technology. Most of the customer and the partners that are looking for this technology is for the enterprise feature of ZFS. Some of them are summarized in this slide. I would like to highlight the compression. We saw that today that many of the sites that are currently using compression in ZFS can get a ratio of 1.6, 1.5. That means a good, very good return in your investment on the storage. But also is interesting the functionality that you can have with ZFS, including the clustering of the copy that is provided by copy on write, the increasing in the serviceability of Lustre with zero offline file system check. But also, again, increasing the return of investment in the storage, lowering the total cost of the storage solution, enabling JBOD and more less complex storage solution for ZFS. An interesting aspect of ZFS is that he can really manage efficiently SSS, new SS disk technology, new non-volatile memory technology. Is a very nice functionality that really can give you the possibility to increase the number of IOPs that you have on your OSTs. So, this is a slide regarding the history of ZFS. We started developing an abstraction layer for object store target, the OSD, that give us the opportunity to don't support only XT4-like backend file system, but also other. ZFS is an example. Wednesday there is a speech regarding BTRFS as a backend file system. So with this layer we can support several different backend file system. And also it's interesting how we can also create a hybrid solution. For example, I have several customers that are using metadata target on LDiskFS, and for the object store target they are using ZFS. It's completely transparent for the clients. There is no problem. And Also, another important thing is that from starting the new version of Intel Lustre, Intel is supporting Lustre on ZFS and also ZFS. So basically, when a customer open a ticket on Lustre on ZFS, they can have support from us also on the ZFS part. We know the telephone number of Brian Berendorf, so it's easy. So this is the actual implementation of Lustre on ZFS. Actual means that we are developing something in order to I don't know if you see the red. In order to implement also the ZFS IO pipeline API on Lustre, but at the moment what we implement is something at the DMU level. So this means that ZIL, ZFS intent log, is not supported, but L2ARC devices are very well supported. The process to implement ZIO device is under very heavy development in this moment. So, a slide for performance. We saw the very nice presentation of Rick, and we understood that, and the fact that the sequential I/O is well managed by ZFS is a fact. We are improving the record size of ZFS. At the moment is available only at 128K, and this ticket in the Jira website and this patch from ZFS give you the possibility to increase these block size. The goal is to achieve 60 megabyte as a record block size for ZFS. We have 1 megabyte at the moment as patch, and we want to improve in order to arrive to this number. At the moment, the plan is to include this patch in ZFS version 0.6.5. There are also many other improvements that we are inserted in the OSD ZFS layer that you can find from the presentation of Rick. Random I/O. One of the problems with Lustre is the small files random I/O workload. With L2ARC devices and ZFS, you can use very easily SSD's device in order to increase the number of IOPs from your object store target. And this can be used only for reads, okay? So every write are not improved by this device. The ZFS intent log development can help with fsync. At the moment, also fsync that is typical when you write a lot of small file could be typical when you write this kind of small file could be a problem. And also inside the Lustre there are some activity that request a sync call. Like commit on share, or if you enable this functionality. Metadata. Metadata is another aspect that we would like to improve as performance. At the moment, many customers do the fact that the metadata is not really as fast as LDiskFS, prefer to use LDiskFS as backend. But we are really developing several new functionality, and we are very involved in this activity. But I don't think performance is a big problem with ZFS. We are improving, we are working very hard on this. Also, the reliability of ZFS is legendary, I can say. Probably not all are really, but yes, ZFS is very robust as a file system. We can do end-to-end checksumming with Lustre and ZFS, because in Lustre the client can checksum until the server, the RPC in flight, and the ZFS can checksum from the server to the block written on the storage, but is not integrated. Okay. Any error is triggered, but is not integrated. It's very interesting, the resilvering. Resilvering is the capability of ZFS to rebuild a write group. Basically, resilvering is very different from hardware and software, the traditional hardware and software RAID, because resilvering is the rebuilding time is based on the utilization of the file. So and also is a top-down activity. So you can start rebuilding the latest block touched. And also is safe to stop the rebuilding and restart when you want. Okay, so it's a very robust activity. We are thinking also in every case to improve the performance of ZFS, creating a declustering ZFS configuration for our partner, suggesting this kind of configuration in order to have all the bandwidth available for the resilvering activities. Another very important capability of ZFS is the fact that ZFS can correct corrupted blocks on disk automatically. This is something that is not available in any other software RAID. Software RAID by definition can't know if a block that is not in parity can fix the block, because he doesn't know what's going on in the file system. So basically with ZFS and the fact that ZFS is has a write capability but also is a file system, ZFS can really fix corrupted blocks in the event of silent data corruption. But how we lose when scrubbering and resilvering is starting? This is an experiment that I did in one of our cluster. Basically, the cluster has 4 OSS, and I have started a scrubbering and resilvering activity for all the IOR benchmark on one OSTs. Okay, and as you can see, the write is completely unaffected of the repair activity. Only reads are affected. So it's very interesting how how efficient is ZFS during the rebuilding and the scrubbing time on write. Availability. Availability is not a problem. I have developed some script for Corosync and Pacemaker to import, export the pools. The only problem is we don't have multi-mount protection as for LDiskFS on ZFS. When you import and export the pool, if the pool is already imported in another node, you don't have any protection. So you have to belong to the robustness of Corosync and Pacemaker to don't mount or to don't import the same pool on two nodes. We are working on implement multi-mount protection in the future in order to leverage the high availability of the solution. Serviceability is, we have here problems and very good solution. The very good solution is the serviceability that you can have with ZFS, because with ZFS you don't need to do file system check offline. Okay, and this gives us a very good serviceability of our file system. And also with the LCTL Lustre file system check online, you don't need to put offline your Lustre file system in order to do the Lustre file system check. So these two functionality give you a very, very high serviceability of Lustre with ZFS. The main problem for a system administrator is the configuration of ZFS in a very big environment, especially if you are using write-Z and JBOD. So basically you will have in a normal JBOD with 60 hard drives and a multi-path configuration, so at least 4 expander to access the JBOD. If you have 60 hard drives, you have 120 SCSI devices to manage in your Linux server. You have to align the multipath configuration with the chain, with the expander, the SAS driver to the hard drives that you have. So it's very complex. So this is why Intel in this moment are working with partners in order to create reference architecture versus work with end user. We want in this first support of ZFS to work with partners to create a reference architecture, certified JBODs, certified solution, because we really see a major problem here in the administration of this solution. Another stupid problem is to blinking hard drives, because most of the enclosure are not designed to work with SAS card, but are designed to work with a write card. Okay, so it's not only not all the JBOD are able to support SCSI enclosure service protocols, or they have their own protocols. So there are some script that can really help you on that, but should be integrated. And again, this is why we are working with partners in order to create a reference architecture. ZFS event daemon is a very good innovation that the ZFS team include in the latest version of ZFS. So basically, this event daemon can trigger IO error or what's going on the ZFS file system and make some action. But again, we need partners that create script in order to make this action. A simple action could be add and not spare hard drives in your pool. Okay, so this is something that should be created by our partners in order to deliver to end user the ZFS solution. We help the management, the serviceability of ZFS on Lustre, including the DKMS support. So basically, DKMS is a technique to rebuild on the flight a Linux module when the version of the kernel change or when a version change in the modules. So these help you really to simplify all the management of Lustre version versus kernel versus ZFS version. So in this very busy slide, I would like to give you an orientation how to design a ZFS storage server for Lustre. So we saw from Rick that, and we saw in many POC that CPU frequency, CPU performance matter, especially if you are using RISC-Z. Not only because I'm Intel, I want to sell you silicon, but really when you design a ZFS storage server, please, if you plan to use RISC-Z devices, please use high frequency CPU versus low frequency multi-core CPU. RAM is very important. ZFS is robust, okay, but is copy and write. If you have memory corruption, you have file system corruption. Okay, so ECC memory is very important. A lot of memory. Okay, so 128 gigabyte is what we suggest, at least. Storage, even if you use RISC-Z2, we suggest 8+2 type of configuration for your object storage target. We also suggest to use the stripe capability of ZFS in order to put together in a striping mode several VDEV, RISC-Z2 VDEV, in order to create more or less object storage target for each server. You can take advantage of L2ARC, so you can use SS disk. L2ARC is random read-only acceleration. So you can select, for example, Intel SS disk that are very, very good in read performance. I did this experiment in my lab. So basically we have two tests, one with one without the L2ARC, and as you can see, the number of IOPs that I achieve with L2ARC is like 10 times, 8 times. 8 times of the IOPs that I have with the normal, the OST without L2ARC. This is a specific benchmark that I did using our DCP 37 3700 SS disk. So, another problem with ZFS is that ZFS is not running only for Lustre. It's running for many other use cases, many other workload. So there are a lot of tunables for ZFS that are not really designed for Lustre, but are designed by the experience of Brian and other guys. So there are at least, I don't want to go through all of them because I have only 5 minutes, but please try these suggested tunables for your specific workload. This presentation will be available for all of them, all of us. So based on your workload, my suggestion could be okay, not good, but some of them are pretty general purpose. Another important thing is to tune is the memory, because again, for example, the memory used for ARC is only half of the RAM. But if you are designing a ZFS storage server that are running only ZFS, we can increase the ARC memory, okay? And also the memory for the metadata activity is only 1/4 of the ARC by default. If you have a metadata server that are running only metadata information for Lustre, probably you want to increase these sides. And in experiment that I did, increasing the metadata limit can increase the number of stat per second that I can have from my metadata ZFS server. Okay, so this is very important. Okay, just with the same side, just changing the tuning the ARC meta limit. So another interesting thing is the ZFS I/O scheduler. The ZFS I/O scheduler is recently introduced in ZFS. Is a very smart way to manage the I/O, and for example, this gives us the possibility to manage, to optimize the rebuilding and the scrubbing time, but also should be tuned for Lustre. And one of the things that we suggest to tune is the asynchronous write rate. So we suggest to decrease the trigger for the dirty data max from the 10% of the RAM that could be a lot if you have 128 GB of RAM, and put a limit between 1 and 4 GB. And then increase the number of write, the outstanding write that you have when you hit the dirty data max. So I'm pretty much at the end. I would like to give you the possibility to ask a question. So performance, we are working to increasing the ZFS block size, the metadata performance, and optimize the Lustre code for ZFS. You find the LU number to follow this activity here in my presentation and also in the presentation of Rick. We are working to support the ZFS intent lock device for the workload that are that having a lot of f-sync, and we are thinking to implement ZFS tunable during the MKFS and mount time. We did this in the past for other things, so could be nice if when we mount the Lustre file system on ZFS, we can tune something that we are really know that is good for Lustre. On the reliability stuff, we are working for the clustering ZFS and also multi-mount protection for ZFS for the high availability. On the serviceability stuff, we are working to integrate ZFS event daemon and also the creation of ZFS VDEV using our Intel manager for Lustre. Okay, that's all. Any questions so far? Is there a question there?
So for the LUNs within the VDEVs, are those concatenated or striped, or how's the, why is that providing a benefit? And I guess, is that appropriate as an approach to deal with ext4 on non-ZFS backend?
Sorry, say again.
Is the concatenating or the striping of the LUNs to create the VDEV group, right, so you're reducing the number of OSTs on the backside.
Yeah.
Is that appropriate? So are those striped or concatenated was the first sort of question, or is there something else? And is it appropriate to do that same sort of optimization on ext4? It's not appropriate or applicable. So why do you get a big win out of VDEV by doing managing your LUNs that way?
With LDiskFS, you can do this directly with ext4 because you need something, a software RAID that can do this for you. For example, our friend Seagate created this grid RAID with one single OSTs using LDiskFS as backend. Okay, so depend of the storage vendor that you select, because out of the box ext4 is not able to do that. With ZFS you can do this because ZFS is file system and RAID together. And we suggest this for specific installation when the number of OST is incredibly high. Doesn't make any sense to have 200 of OSTs. Okay, you can reduce. Normally, historically, we give a ratio of 4-6 OSTs for each object storage server. Okay, but now with the size that we have today, we are talking people that want 50. 100 petabyte of file system. The number of OSTs could be so big that we encourage to decrease the number of OSTs. Okay, it's a trade-off, depends of you. In the other hand, if you have several OSTs, you can leverage the number of IOPs that you can have. Okay, so it's a trade-off. In people that are looking for ZFS are looking for very large installation. Okay, they can put compression on top of them in order to have. So in this case, we suggest to decrease the total number of objects or target. Otherwise, you have 2,000 of objects or a target, and is
okay.
insane.
So, but there's not a performance gain that you're seeing from that. It's more of a manageability.
This is interesting because it's a trade-off between the efficiency of the striping of ZFS and the striping of Lustre. So you can measure based on your workload who is the best, who has the best efficiency. In my perspective, I suggest to use the ZFS approach. I saw that sometimes is more efficient.
So, I mean, do you see like an ability to either drive larger RPCs from the front end or to concatenate the writes potentially more effectively, so to reduce the number of transactions on the back end as a
yes,
result?
especially the trend is now to increase the RPC size. Okay, we have 1 for probably in the future 16 megabyte. So
I can address some of your concerns as well. At Livermore, we reduced the number of OST counts, right? We used to have a DDN file system that was 4 petabytes, and it had 960 OSTs on it. Sequoia, that's 55 petabytes, has 768 OSTs on it. And we went through and did the calculations, and we measured. Each OST was consuming about 1 megabyte of RAM on the clients. So when you have 4 file systems mounted, you start to chew up 3 gigabytes of RAM on your clients, and the users don't have that memory available to them for their applications. So that's another advantage. Reducing OST count reduces client-side memory usage.
okay, thank you.
Gabriele Paciucci.
Gabriele Paciucci.